Hey, boy, real problems right now. My keyboard is not working, so right now without a keyboard. And if I could teach this class without a keyboard, boy, I'm using the on-screen keyboard right now. Hey, all of them really do a little in maths right now, boy. Yeah, so let me see. How are doing this on-screen keyboard? We're trying to bring up here, boom, bang, enter. Oh, all my copy and paste, I gotta do that manually, boy. Hey, distress. All right, continue start up there. Oh, yeah. So what is he seeing? What is he seeing nevertheless? How things? How is life? Good night, everybody. I hope you're studying going well. Fortunately, I think my you supposed to still be working with you working. So what we supposed to get done today, algebra? Everything that could go wrong right now, yes. Then are you upside down? How they manage to do that? How they manage to do that? When I'm missing a session, let's go look. Like I get hacked, yes. So you see it writing, but writing the wrong way. Say 0. All right. I think we getting somewhere. Let's see writing. Let's see writing. Let's see anything. We getting somewhere. Praise the Lord. Let's hey, for 4 months, boy. When it going good is performance. When it going bad is them problem. I tell you, yeah, you're supposed to be hitting them some algebra today. Algebra. Make it look good. Algebra. I can't write right now. My keyboard now working. They have brand new computer and a real good computer. And keyboard and working. Algebra. And algebra comes in question 2. So we're looking at number 2. So let people them know we getting through. And by the way, we always switch in the school. Well, you kind of already know what school it is. You could kind of see it in the back. What school is this? Anybody from the school? Different background. If I bring it up in full, you're going to be able to read the name of the school. Yes, you can see the name of the school already. Bang, you can see the name of the school. Pick up anybody from that school. All right, we just jump into some work one time. Lock in, everybody. So according to Shadrach, lock in. I see when I came in 1 minute late, Shadrach was like, "Sir, lock in, sir, lock in." Big up Shadrach and that coined it. I feel like we phrase for this year. Lock in. So the first thing we're gonna do is the question from I believe January this year. And what we had. Now keep in mind I can't even copy and paste right now. First things straight. So because normally I have a little shortcut that I press to copy and paste now. But I use my mouse for everything. So there's a little different skill I had to learn here right now to use the mouse for everything. Normally I used to be using shortcuts right through. I can't even see the paste button. Where's paste? Have you seen it? I might be able to do my thing how I do my thing. CTRL-V or the CTRL-V. Screenshot. Seeing screenshot. Print. No, brother. Just give me a little second there. I struggling the good fight right now. I may have to write on the PDF. 400 viewers. Everybody, find a seat, find a seat. Welcome to the first live. Those of you all watching in the future, y'all could skip ahead. Tonight I'm going through some real tension here because my keyboard is fighting me down. Is there a manual button I press to turn off this keyboard on this computer? Boy? Because what in the world? It's always be these best computers that get these stress. So we starting ready or not, we starting in like 4 minutes. In 3 minutes, 7:10. We are a little behind time. I'm just double checking if I have another option that I could use rather than having to write on the PDF. It looks like I'm stuck with that for now. This is question 1, ladies and gentlemen. You should see it on your screen there. Yeah. And in question 1, the diagram below shows the front of Pinky's house, which uses 4 windows and a door. What is this? What do you find? What do you think about this question? So I remember we in algebra, and I said one of the things is that they combine geometry and the topic. So it's 708, not bad. So always have a contingency plan. Contingency plan is to write on the PDF, which I have some skill in that too. So I feel like we're gonna make we find some kind of area or something here. Calculate the total surface area of the front view of Pinky's house, inclusive of the window and door. How are you doing that? How are you doing this now? How are you doing this, ladies and gents? Some kind of geometrical shape, compound shape, and we need to get the total surface area. This is a question 2. I open the right thing here, boy. Nah, I feel like open the wrong thing. This is a question 2. What is this? This looking like algebra at all, yeah? Hey, real stress today, boy. Algebra. Right, this is what we should be looking at. I want to know how the front of Pinky house come out in that. What we was looking at there just now. We was looking at that paper 3. All right, we in the game day. Everybody, locking. Sorry for the late start and the rocky start, but pain. So this is January 2024. We needed to simplify this, and yes, this is a popular thing. So what is this step to do? What's this step here? What's these steps here? What's these steps here? So it looks like we need to go into the realm of factorization. Factorization, right? And what are the 4 styles of factorization that pops up for CSEC? We spoke about this. The 4 styles of factorization that we can get for CSEC is the basic factorization, difference of 2 squares, grouping, that's when you have 4 terms. So I just literally call it 4 terms to help students identify it. 4 terms factorization. And of course, we have the quadratic factorization, quadratics. All right, so we had a basic difference of 2 squares, grouping, quadratic. So let's go back to the question. What type of factorization is this on top here? Well, this is like a piece of a quadratic, but because there's no C, you could just call this basic factorization. That's just normal basic factorization. So we can say this is x into x plus 7. What is, when you're doing basic factorization, you ask yourself what is common, then you ask yourself what is missing. 2 questions. What is common, what is missing? So let me show you it in a quick step here. For example, if I have x cubed by y plus, let's say 3x cubed by y plus 6x squared by y to the power 5, what is common? What is common? What is common there, people? Let's say we will ask the factorizer, what is common between these 2 terms? Between these 2 terms, what is common? Well, I'll put it in blue. 3 is common in the numbers. 3 could go into both of them. x and y is common, but how many x can we take out? We can actually take out a x squared, right? Because this has x to the power of 3. This has x to the power of 2. You always take out the lowest power. So like x squared, both of them could give up 2x's being multiplied by each other. Both of them could give up a x squared. And both of them could give up at least a y. This only has one y to give. This has 5 y's multiplied by each other. So we'll put a y there. So you answer the question, what is common? Now you answer the question, what is missing? So this is common, what is missing? Missing, there's an x missing from the first term to get to x cubed. And we're missing a 2 from the second term to get to 6, 2 by 3, you understand? You understand what I mean when I say what is common and what is missing? X squared, we already have x squared. Y, well, we need y to the power of 4. So you end up factorizing, you get this. So that's how basic factorization would look like. So if we go back to the question, we'll see that we asked ourselves what was common between x squared plus 7x, and it was just an x. Both of them could give us an x. So since both of them could give us an x, we took it out, and then what was missing? And x by x will give us back the x squared, and then x by 7 will give us back the 7. So then we're going to see how to factorize this part here. How do you factorize the denominator? What is that? We see that x is being squared, so that's a square number, and 49, we know from our square tables, that's also a square number. 7 by 7 gives us 49. So when it's difference of two squares, there's a way to do difference of two squares. Dots for short, right? Difference of two squares. And I'll give you two easy examples: x squared minus 9, 4x squared minus 25, and then I'll give you the complex example. A complex example would be like 4x squared minus 16, right? So let's put a 9y squared here, just so you understand it could have weird things, right? So in the first example, you want to get the square root of each term. X squared is equal to x. The square root of 9y squared is equal to 3y. Verify that. And then you write, therefore, x squared minus 9y squared must be equal to. The principle is once you have two numbers being squared separated by a subtraction sign, once you have two numbers being squared separated by a subtraction sign, we can write this back like x minus 3y by x plus 3y. So you take, it's like you take this, the x and the 3y, and you put it back there. And the only thing that changes is the sign between them. If you understand difference of two squares, type I understand. IU for I understand. The next one, if we find the square root, if you want to undo and I can't undo. Hey, not having a keyboard is a real pain, but I feel in the fight. So the square root of 4x squared is actually 2x. The square root, because the square root of 4 is 2. The square root of x is x. X squared is x. And the square root of 25, you could let people know we back in full swing. We get a little hiccup. We take like a little 10 minutes to sort out ourselves. And by we, I mean me, but we in full swing now. So then you could write, therefore, these three dots mean, therefore, 4x squared minus 25 is really equal to the 2x minus 5 by the 2x plus 5. Now you might be saying to yourself, he said the last one was hard, but the last one not looking hard to me. The last one looking easy. So what would be wrong of you to do is if in the last one you get, what would be wrong if you get 2x minus 4 into 2x plus 4. That's wrong. Anybody can tell me why that is wrong? Why is that wrong? So all of these questions in CXC usually come with this instruction. You want to factorize, and they put a word after the factorize. What's the word they put after in CXC? What's the word they put after? So this looks correct according to the rules of difference of two squares, but it's not wrong in the sense it's not that it's not equal. It's not that you didn't. The problem is you didn't factorize, and the word that they have after is completely. Who said that? Emmanuel VIP, all you know what you're talking about. So they want you to factorize completely. And if you look at these, a 2 could come out of both of these. So what you always want to do is take a little watch at the question and make sure you don't see a little common factor between the two of them. Like between 16 and 4, there's a common factor of 4. And if we pull it out, we will get 4 into a basic factorization, right? 4 into x squared minus 4. Why is in the chat if you understand what I did there? And CXC does this a lot of times. And is one of those questions. There are a few questions in CXC that you could do, think you get correct, exam finish, and you never ever know you get it wrong because you feel like you get it correct, but they will take away a mark. So you understand? Why for yes, if you understand, I took out the 4. So now I have x squared minus 4. So this is equal to 4 into, and now is where I do the difference of 2 squared things and I get this. This is the answer actually. This is the answer. So I observe the square root of this and the square root of that. Please learn that because this comes like about anytime they bring difference of 2 squares, you always have to be on the lookout. I would say maybe, how much y'all would say, those of y'all who study a lot, how much y'all would say? I would say maybe about 30% of the times. Maybe about 30% of the times it comes with a hidden factor. And if you don't factorize completely, you just lose a 1 mark. So I just teach you how to clean up 1 mark. Now, a couple of people in the chat need a little extra explanation. So what I want you to do is look up Kerwin Springer factorization. We're going to do lots of questions like this in today's session. So you'll get to see it over and over again. But if you need a little full explanation, look up Kerwin Springer factorization and watch that video and soak it in. Marinate in that video. So from this, we should be able to understand that this is actually x minus 7 by x plus 7. And now something becomes apparent to us. What are you seeing there? From this, I'm seeing that I have two products, x being multiplied by x plus 7, and x minus 7 being multiplied by x plus 7. But I have common factors on the denominator and numerator. That's like if I had 2 times 10 over 2 times 20. And I cross all them zeros, but I also cross all the 2s. So I could come and cross all this and cross all that and finish off strong. Strong finishings here with x over x minus 7, which is the final answer. You understand? And now I've simplified this and I'm looking good. Next one is to find the value of r when x to the power of 2 multiplied by x to the power of 6 is equal to x to the power of r. So what is this? What topic is this? What topic is being tested here in these two questions? There's like 3 words for this topic. 3 words. Let me know who say it in the chat. You could call it indices. You could call it powers. You could call it exponents. All of them mean the same thing. And that's when you take a number and you, okay, from primary school, back in the days in primary school, right? You here in primary school with your big bag. Happy. You know it, a thing like CXC even exists. So that you did. Back in the days of primary school, you know what they tell you? They told you that multiplication, or they're supposed to tell you this, I'll let me tell you this, is repeated addition. Anybody else paying attention in standard 3, standard 2? Multiplication is repeated addition. And what they meant by that is like if I have 2 times 4 or 2 times, I'm not even use 2. Let me use 3. I'm going to end up using the 2, yes. 3 times 2. What they mean is that this is really 2 being added to itself 3 times. Yes? Oh, shucks, I put extra 3 in the back. It should be a 2. You all agree? Well, they're supposed to introduce this kind of concept down the curriculum. They're supposed to introduce multiplication like repeated addition. So when you multiply something, it's like you're adding it over and over. Well, here the thing. Here it is. Indices is like repeated multiplication. Ooh, you never think of it like that, right? Indices is like repeated multiplication. So like if I have 2 to the power of 3, 2 to the power of 3, it come like I'm saying multiply 3 by itself 2 times. 3 times. Multiply 2 by itself 3 times. You catch the kind of link there? And from this concept is where all the rules of indices are booted from. From this concept is where all the rules of indices are booted from. So if I tell you these are the rules of indices that you need to know for CXC, if I told you I have 2 to the power of 3, and then I want to multiply it by 2 to the power of 4, what I'm saying is that I'm repeating the multiplication of 2 3 times, 2 times 2 times 2. Then I'm repeating the multiplication of 2 4 times. But then, if I step back and look at the whole big picture, that means I repeated the multiplication of 2 7 times. So that is really 2 to the power of 7, which is why when you multiply indices of the same base, you have to, the instruction is to add the powers. You add the powers. If you understand that, write 10 out of 10. Add, I'm trying to switch my marker here to make the thing look good. Add the powers when you are multiplying. And from this, we get more rules on it. So like if I have x to the power of a multiplied by x to the power of b, fine, we add the powers. This is x to the power of a plus b. If I have x to the power of a divided by x to the power of b, this is actually subtract the powers. And we could look at it with an example again, very quickly. If I have 2 to the power of 4 and I divide it by 2 to the power of, let's say, let's say 3. Well, let's say 3, yeah. This means I have 2 times 2 times 2 times 2 divided by 2 times 2 times 2 times. Stop. And then you cross out, cross. You just end up with 1, 2. This is 2 to the power of 1. I subtracted the powers. More rules arise. So we learned in indices, if you have the same base, I could sometimes in the textbook you might see the base is a. A to the power of m multiplied by a to the power of n, add the powers. If you have subdivided going on, you subtract the powers. If you have a power going to a power, you multiply the powers. If you have a negative power, you invert. All of these can be, all of these things you can understand it using the same concepts that I show you. You could set it up and try and figure it out. I don't have the time to go through it right now. If you have a fractional power, once again, you could prove this using that. If you have 1 over 2, it's actually the square root of a. So it's really the second root or the square root. You don't need to put the 2 to the square root. Even if you have a symbol like this, let's not put the m, let's just put 1. This really is tested in the multiple choice. There's a question in the multiple choice. You will get the nth root of a. So I hope all you're feeling this and it making a little more sense than when you was learning it back in the days. It hitting home a little more. Maybe it tickling the brain cells a little more. So this is what is tested a lot in that middle piece in number 2. So let's go and see how we can apply that knowledge. X squared multiplied by x to the power of 6. What they are telling us is we are multiplying something and it has the same base. So the instruction is not to multiply, but to add the powers. So this is x to the power of 8, which is being expressed as x to the power of r. Therefore, comparing the powers, r is equal to 8. This one is a little more interesting. This one is a fact. So what are we going to do for this? This is a number fact. 8. CXC is fascinated by 2 to the power of 3 and 2 to the power of 5. Let me write that down. CXC is fascinated. Fascinated. That's why it's spelled fascinated. By 2 to the power of 3 and 2 to the power of 5. Them love it. Remember, I tell you that. So when you sit in the exam, you know. This is the same as 2 times 2 times 2, of course, which is 8. And this is the same as 2 times 2 times 2 times 2 times 2, which is 32. Just know these things off. Just know these things off. 2 to the power of 5 is 32. 2 to the power of 3 is 8. Of course, 2 to the power of 4 is 16, and 2 to the power of 6 is 64, 2 to the power of 7 is 128, and all these other things. You could work this out. You could type it in your calculator even. But you see this one, 2 to the power of 3 and 2 to the power of 5, they love it. So from this, we can look at this question now. S to the power of 3, and remember, we could recall, we could be like, recall that 2 to the power of 3 is 8. Therefore, S to the power of 3 is the same as 2 to the power of 3. And comparing the bases, it's obvious now that S is equal to 2. Nice. Let's move on. The diagram below shows a triangle. Oh gosh, even zooming out is a task. A triangle and a quadrilateral. All angles, right? So they bring the geometrical thing here, and we have algebra in this. All angles are in degrees and are written in terms of A and or B. For the triangle, 2A plus, do you need to, show that. Is a show that question. Remember, the most audacious question, the audacity. The most audacious question in CXC is a show that question. Why is it audacious? It's because it's like they are dangling the answer on a rod in front of you and say, answer, this is the answer, just show me how to get it now. They the answer. Which is really audacious. If you stop to think about it, they are saying, this is the answer. Show me how to get this now. Right? So how do we get this? Now, some people say I'm moving fast. I'm actually moving at a slightly slow pace on average. So if you find I'm moving fast, just write down the topic and look it up on the channel, look it up on Google, search my name and the topic and research it. Review it, right? For the triangle, show this. What do we know about internal angles in a triangle? We need a fact. We need a fact. Most of the times in a geometrical question, we need a fact. What do we know about the internal angles of a triangle? Well, we know that all the angles in a triangle add up to a specific number. Let's go look at some facts. If there's no two-sided shape, anybody know about that two-sided shape? I don't know about that. The first shape we have, plane shape, is three-sided. And all the angles in a three-sided shape add up to a number. All the angles in a four-sided shape add up to a number. All the angles in a five-sided shape add up to a specific number. A five-sided shape is called a what? Six-sided. All of them will add up to a number. Well, all the angles, the internal angles, we call them internal. In a triangle, three-sided shape, adds up to 180. In a quadrilateral, I don't want to say rectangle or square. I want to say quadrilateral to encompass every type of four-sided shape. And you need to know all your quadrilaterals. Do you know all your quadrilaterals? Can you name at least 5 quadrilaterals? If you can't, it's time to begin. Look it up. They test that once or twice within the new switch of the syllabus. Look up, understand what a rhombus is, what's a kite, what's a parallelogram, what is a square and rectangle, and of course, what is a trapezium. CSEC loves trapeziums. Go and look, write down all them names and make sure you look it up and know the properties. It might save you some marks in the future. So all the angles in a quadrilateral will add up to 360 degrees. In a pentagon, how much does it add up to? Pentagon, how much would it add up to? How much would it add up to even further into a hexagon? Well, I never really learned these off. I will tell you the one fact that I always do. The external angle, one of the external angle, will always be 360 divided by n. Now, the one thing I hold with me and I walk in the exam room with confident in a regular polygon. So I'm giving it to you now. I'm bestowing this upon you. This is be handy. It might show up in your multiple choice or maybe even in your paper too. Pretty high chance. So the external angle, you must see on them, what in the world is an external angle? Okay, let me show you. That triangle there. If I extend one of these sides and I do so, ta-da, that's an external angle. This is a square or whatever there. If I extend one of these sides and I do so, bang, that's you catch it. Catch it. Let me draw a hex. This is a hexagon there. If I extend one of these sides, it looked like a side was trying to extend itself there already. And I do so, bang, that's the external angle. And what I am telling you is this formula will always give you that 360 divided by the number of sides. N stands for the number of sides. Are you with me? Good thing I'm telling you, you know. Memorize it. Some of you good in maths and probably didn't even know that. So 360 divided by n is the number of sides, and this will give you the external angle, one external angle. And it's for a regular polygon. Regular just means all the sides are the same. So what does this tell us? This tells us that this angle will be 360 divided by 3 sides in a triangle, which is 120. Agreed? This angle will be 360 divided by 4 sides, which will be 90. This angle will be 360 divided by 6 sides, which is 60. And now that I know the external angle, to find the internal angle of a polygon, subtract from 180. So it means the internal angle here, I'm going to do them in blue. It's going to be 120. The internal angle here subtracted from 180 is going to be 90. The internal angle here is going to be 60. Check it out for other shapes. Let me just throw in one more shape. One more shape. I'm teaching a little geometry here. Let's throw back in the pentagon in this. If we extend this, and 360 is a beautiful number because it has a lot of factors. There's a special name given to numbers with a lot of factors. 360 divided by 5 is how much, class? Somebody tell me in the chat. 5, we're going to 36, 7 times, bring across the 1, 5 into that. 72. You look at 72? So 72 on this side. So what's going to happen on that side? What is the internal angle? The internal angle is going to be well done, class. 72. So the internal angle is going to be 108. Well done, Sadia. This round. So, or Sadia. 108 degrees. All right. So you understand the real thing there. You equip with some knowledge there. And that also means to find out how much angles in total, you just multiply the sum of all the internal angles, you multiply by how much angles there. So 108 times 1, 2, 3, 4, 5. 108 times 5, and you get the sum. But this is very important. This could save your life. I hope you make a good mental note of that. But back to the question. The fact here was very simple, actually. The fact here was stating that these triangles need to add up to 180 degrees. So I will just put down that A plus 2B plus 3B plus A plus 9 must add up to 180 degrees, bringing across the only number, which is 9. I will get 180 minus 9. Adding up the like terms, the A with the A, I get 2A. The 2B with the 3B, I get 5B. And in the end, my last line will look exactly like this. 2A plus 5B is 180 minus 9 is 171. I get my 1 mark. I showed that. For the quadrilateral, show this. See the fact coming important here in this question. This was January paper. We had to show that all these angles add up to all the sum of the internal angles in a quadrilateral will add up to 360. It don't matter that it's looking weird and abzucky like this. Still hitting 160 fam. So you're gonna be 6a plus 3a plus 2b plus 18 plus 3b plus fed up plus running out of space plus going to show you the solution direct because I the solution type up here. See? Oh no, wrong solution. Wrong solution. Only it coming. I just ain't feeling to write all of that right now. That'll give me the black. Boom. Wham. You see? Answers are there. Answers. Proper things. So yeah, have all of that. And of course, you're gonna gather all the A's together and let them party. You end up with 7A. Yeah. Gather all the B's together and let them party. You will end up with 8B. And then you bring across that number and subtract it, and you end up with that, which is what you're trying to prove. This symbol here just means you prove what they're trying to prove, right? Quad erat demonstratum, it stands for. Solve the pair of simultaneous equations in 1 and 2 to find the values. Ooh, so we got a beautiful simultaneous equation to solve up. So this is 2a plus 5b is equal to 171. 7a plus 8b is equal to 342. This is worst case scenario for a simultaneous equation. What you see before you here is the worst case scenario for a simultaneous equation. Just now, I just want to be able to write it on the board here so I could get more space. So it's 2a. Actually, there's no worst case scenario. It could be worse than this. It could be one linear, one non-linear. But what I'm saying is that none of these numbers just directly add or subtract from each other. So what do we do in a scenario like this? This is a good time to show you how to solve on your calculator. Because this is definitely a question. If you are just getting by in maths, I would advise learning how to do it on your calculator, how to do the simultaneous equations on your calculator so you can watch it like in the exam and know that you get it correct before you jump in. So are you ready to see how to do it on your calculator? Maybe you released a little gasp just now. You can solve a simultaneous equation on your calculator. Yes, you can. I'm about to show you. So remember, my keyboard stopped working just before class started. I mean, like literally, I was about to come online and my keyboard shut down. I reset the whole laptop. The laptop keyboard now working. I reset the whole laptop, and then I had to bring on the on-screen keyboard because I really didn't want to miss class. So you could even solve simultaneous equations on your Sharp calculator. Those of y'all who want to know how to do it on your Sharp calculator, long ago, 5 years ago, Kerwin Springer of YouTube did it on his Sharp calculator, and I made a whole series of how to get the best out of your Sharp calculator, so you can go and watch it. Most people in the Caribbean don't have the Sharp calculator, but I'm advising, and more students are getting this calculator, right? So here's how we do it. We're going to press mode. Then you've seen 1, 2, 3, 4, 5. You've seen 5 have EQN. What do you think EQN stand for? Equation. So press 5. Now you've seen some things here. If you understand your algebra and your subscripts and your superscripts and stuff really good, you know that this showing a linear equation in the form ax plus by equals c. And ignore the ends, right? This one's showing a linear equation as well, but it has 3 variables. Like when you reach form 6. This one is showing a quadratic. So you mean to say we could factorize quadratics on the calculator too? Yes, we'll do some today. I'll show you how to do that today. This is a cubic polynomial. Once again, that's when you reach form 6. Ignore that. Praise the Lord, you don't need to learn how to do that. So we're going to click 1, of course. You're going to click 1. Bang. Now you're going to type in, what do you think you're typing in here? The coefficients. So you're going to put 2. That's the coefficient, meaning the number in front of the letter. So that is 2 we're going to put there. Bang. And 5. Bang. Equal is like enter. So you write it and then you press equal. And then you put 171. Press bang, bang. And this is going to ensure that you secure the bar. 7, 8 are doing the next equation. And this equation 1 and 2. Making sense? It's like you're putting it in a big matrix. 342 equal, and then you're going to press one more equal. X is 18 and Y is 27. And let's make a note of that. You're going to be like, yes, dog. Yes. So X is 18, Y is 27. So you have that day. In fact, you could write that on your paper. Now, you'll show your CQ at least one mark. So now is to go through this and see if you could solve this at a quick pace. Since you know the answer, if you're really good in math, I would advise the substitution method for this scenario. Those of y'all who are not too good in the substitution method, I'm going to show you the foolproof method to solve using the elimination, right? So if you're in a situation like this, the elimination, what you could do is take this number 7 here and multiply it by that. And take this number 2 here and multiply it by that whole equation. So let's call this equation 1. Let's call this equation 2. So you're going to create 2 new equations, equation 3 and equation 4. And the magic going to happen right now, right? 7 by 2 is 14a. Stay with me. I'm multiplying. 7 is wetting down everything on equation 1. I've seen some people saying their calculator can't do it, and this is the recommended calculator. Ms. Nalini Prasad is actually a math teacher in the student hub. If you could get your hands on this, praise the Lord. If not, you may not be able to get in time for exam. There's this place, Gordon Technologies. Everybody write that down. Gordon Technologies. Go and look them technologies. This man gave me 2 calculators also to give away, I think. You at the ending, I could just pick somebody random and ask them if they have a calculator and give it to them. Because just now on Instagram looking up Gordon Technologies here, making sure. Gordon Technologies. Yeah, Gordon Technologies on Instagram. The number is 7012717. He would have the newer version to it. Don't frighten. It's do the same thing. He know which the version he have is the FX991CW. It's do the same thing. Don't worry yourself. It's do the same thing. So it's like the FX115ES plus 2 second edition. They're making new editions all the time. Casio, like, they can't stay humble and keep the same calculator. Anyhow, or you could WhatsApp this number. He's from Trinidad, right? 868 +1 868. If you're in another country, the best thing I can tell you is Amazon. So yeah, that's the little segue there with the calculator. You could or you WhatsApp him now and tell him, hey, Kerwin Springer send me, I'm looking for a calculator. And you could get that to me in 2 days, or he might be able to get it in 2 days. And you had to practice using the calculator before the exam. I'd advise I want to say, boy, work with just 2 calculators. Work with your Sharp that you're always using and the Casio. So that just in case you're not too sure how to use the Casio, you still have your faithful Sharp, right? Right. Kiki, what is he asking me? Kiki. All your Kiki asking me something some long time now, and I just passing she or he street. Like, we give Kiki a little time to get off the chest. Kiki. 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 Kiki, we not much time now. And the first question still Kiki. This going to be a long session, and all you prepared to go over 2 hours. Kiki! The calculator. Kiki, I don't talk about the calculator already, man. All right, so this is Kiki. So what you lamenting is that I miss you by explaining for other people. Kiki is get problems in relationships and things. It's big trouble for us. Anyhow, 7 times 5 is 35b. And then I want to multiply the 7 by the 171 one time. Kiki, what is that? 171. So I must only answer Kiki. 171 by 7. 1197. 1197. Kiki, you must always be careful in situations like this. 2 times 7 is 14a. 2 times 8 is 16b. And 2 times this, well, we'll get 84, 684. Now, the big numbers can look scary and thing, but don't frighten me, organize yourself. Yeah, Kiki, you must be careful because I alone have a mic here in a Kiki. It's me alone this, you can't defend yourself. I mean, you could type, but you could talk faster than you could type. So then we need to subtract equation 3 minus equation 4. Equation 3 minus equation 4. Now, I can't go through all the whole principles of elimination, but the point is to get rid of a variable, right? So we have 35 minus 16. Why am I doing this on the calculator? 19b. And then we have 1197 minus 684. Bang. So we have 513. Some real weird prime looking numbers here. But so clearly 513 going to divide by 19. And what are we looking to get? 27. And well, they tell me X is Y is 27, but it wasn't Y, it was actually B. But we know that. See how doing it on the calculator itself? Now you know how good you're feeling. Official CXC exam, you're sure. You know, it is to be sure. So then you substitute B is equal to 27 into equation 1. And you'll have 2A plus 5 by 27. 27 is equal to 171. 5 by 27. 5 times 27. And we have 135. We're going to bring that across soon. 2A, you'd end up with 171 minus 135 is equal to something, which is equal to 2A. At the end of the day, you know, A going to sort itself out, and A going to be equal to how much? A is going to be equal to 18. So the answers, you write it in the end, B is equal to 27 and A is equal to 18. So if you need a little more time with simultaneous equations, you know what to do. You know the drill. Write it down. This is a topic you need to revise. Simultaneous equations. There's the elimination method. And of course, there's the substitution method. There are other methods. Of course, there's the calculator method that you now learn. So the calculator method. Make sure you have all three in the bag. And of course, you have the matrix method as well. And the graphical method. 2 other methods to learn. So, we finish the question. 9 marks. What you all think? How you feeling about algebra so far? How you feeling about the algebras so far, there, yeah? Now we scroll and check and see what else there for we. So we need to solve this. 2 over 2x minus 3 plus 3x is equal to 0. What is this? What topic is this, ladies and gents? This is clearly so it's niceness. Yeah, Kiki. Yeah, best friend. So 2 over 2x minus 3 plus 3 over x. What is this? Somebody say quadratic, yes? Let me just pretend I didn't see that. I mean, in the end, it might come out in quadraticish here, so maybe the person have an idea what they're talking about. But the main topic here, I don't know what is called this topic. It's 2 words, AF. So you really don't know what is called this topic? Well done, Elizabeth. Elizabeth, come in the front of the class now, man. Come to the front. Come to the front. Sit down in one of the soft chairs, as we say. Algebraic fractions. Algebraic fractions. So in algebraic fractions, the key is always these 3 letters, LCM. LCM. We want to get the LCM of the denominator. So let's see, we have 2 over 2x minus 3. And what's the next one? 3 over x plus 3 over x. And we needed to solve here. So we need to find the LCM of the denominator. Now, back in the good old days in primary school, you had things like 2/3 plus, let me say, 3/4, and finding the LCM of 3 and 4, it turned out to be 12. 3 go into 12, 4 times you bring up the 4 and you multiply like that. You have the 8. You know what I'm talking about? 4 go into 12 3 times, and you bring up the 3 and you multiply by that, and you get 9. Then you add the 2 together and you get 17 over 12. This is actually coming question 1 still sometimes, right? Well, in algebraic fractions, there's an x involved here. but the principle is similar. As the LCM, we will just put the product. We'll just put the product. So we'll just put 2x minus 3 by x, like that. And then we'll put 2x minus 3 into 2x minus 3 by x, and we'll get the remaining factor come up to deal with the 2. So you get 2x. Then you put x into 2x minus 3. And you put x into this 2x minus the next factor, you're visualizing it, people. You're all visualizing it. You notice the x came up just like how the 4 came up there. And what's going to come up here? The 2x minus 3, right? So what we ending up with? 3 by 2x minus 3. How you all feel about that? How you feeling about that, class? Now I'm going to put this at equal sign like this. I'm going to put equal 0. I'm going to put equal 0 here. I'm going to put this in that arrow, like that. Because they had it equal to 0. And something fascinating is going to happen here. A nice piece of niceness is going to happen here. A nice piece of niceness, right? Just to recap, we got the LCM by putting the product 2x minus 3 by x as the denominator. We went down, come up with the x, multiply by the 2, we get 2x. Went down, come up with the 2x minus 3, come up like that. Well, it turns out that if I have something like this, 3 over 4, or 3, or let me say x under x over 4 is equal to 0. I could just might as well say x equals to 0. Because if I multiply both sides by 4, right? The 4 will melt down with the 0. So if I bring up this denominator on the next side, it will multiply, but there's a 0. So the 0 go in and say use nothing, bro. And then we just end up with the 2x plus, let's expand this one time. 3 into 2x is 6x. 3 by negative 3 is minus 9. For 4 months. And you're feeling good. For 4 months. Somebody might need to write down this time is like 52 minutes into the video. Make a note of that and come back and watch it again. A nice piece of performance just performed it. So 2x plus 6x is 8x minus 9 is equal to 0. Bring across the 9. You get the 9 positive. X is going to be 9 over 8 in the end. And we end off with a nice little ring at the bell. That's the answer for that question. We'll see our next one again. Don't frighten. So we are factorizing. So the second part of your question in question 2, we're going to see some factorizing. You might as well get accustomed. So what type of factorizing is this? We did factorizing just now. We talked about 2 styles. What type of factorizing is the first one? The first one looks like, what does it look like? It looks like, what does the second one look like? What does the third one look like? The first one is definitely basic factorization. Yes, I am seeing the subtraction sign. Where's my undo button? What in the world is that no undo button? Yes, I'm seeing the subtraction. Yes, I'm seeing the squared. Yes, I'm seeing the 4. But is R being squared? Is T being squared? For it to be difference of 2 squares, everything must be squared. Hey, I just remember I need to practice some music for tomorrow. I'm playing church tomorrow. Forget that clean. I hope none of the musicians in church watching me. Right? Anyhow, yeah, I had to practice that. Remind me after this, I had to go and practice. Right? So for anyhow, this basic factorization, because there are no squared there. You seen this squared, this is a square number, this squared, this is a interesting, n to the power 4. N to the power 4 can be written like n to the power of 2 multiplied by n to the power of 2, which is, you could get the square root of n to the power 4. So this is a dot. We can deal with that proper. We come into that just now. Then this is clearly a quadratic. This is clearly a quadratic. So we're going to finally talk about quadratic factorization, and we'll also get to see how to do it on the calculator as well, right? So look, we're looking forward to that. So let's do the first one first. First things first, we can do that right here. What is common? What is missing? What is common, what is missing? That's the two questions we ask when you're doing basic factorization. So common, we can see a 2 can come out of both of them, and an R, and that's it. So I'm going to take out the 2 and the R. As a matter of fact, let me write all from the start. 4RT minus 2R squared is equal to, we take out the 2 and the R. What is missing? From the first term, we definitely need another 2 to go back to the 4. 2 by 2 is 4. We don't need an R. We already have the R up there. We'll need a T. And 2R is already here. We're just missing one of the R's. So we're going to put R. That's the end. Collect your 1 mark, go your way. Difference of 2 squares. There's nothing that can factorize out of this to begin with. So we just go ahead and find the square root of each term. The square root of 9m squared is 3m. Verify. The square root of n to the power of 4 already established that this is actually n squared. So this is really equal to 3m minus n squared by 3m plus n squared. Moving on. So time to go into the land of quadratics. On this here channel, you know how much times I teach quadratics on this channel? Real time. Real plenty time. It's the most popular video on the channel. So if you don't know how to factorize a quadratic yet, you're playing. You want to watch how to factorize a quadratic. I'm going to do it again. I'm going to show you how to factorize a quadratic again from scratch. So, I mean, if this is the first time you learn how to factorize a quadratic, I don't know what you're doing for the 5 years. Let me see how much all is first timers. This is the first time you're going to learn how to factorize a quadratic. If you have first time. 3a squared minus 8a minus 3. 3a squared minus 8a minus 3. Any first timers here? We are going to use the popular AC method, right? Most popular method, the AC method. AC method for factorizing a quadratic. 3a squared minus 8a over minus 8a minus 3. So the AC method wants us to multiply the a by the c, and it wants us to record what the b is. All of this really is supposed to happen in your mind, right? So it wants us to get the product of a by c, and it wants us to record what the b is. The product of a by c is 3 by negative 3. Firstly, what is a and what is c? Well, a quadratic is a equation or expression in general form ax squared plus bx plus c. If it's an equation, it'll sometimes be equal to 0 where they want you to find the roots, right? But let's just put this ax squared plus bx plus c. For example, if I had 2x squared minus 5x plus 3, for number 1, tell me what is a, what is b, what is c. Quickly, guys. For number 2, write number 1, tell me what is a, what is b, what is c. If I have x squared minus 10, tell me what is a, what is b, what is c. If I have number 3, 35 minus 2x squared, 2x minus x squared, tell me what is a, what is b, what is c. So all of these. So for the first one, you should get that a is 2, b is not 5, but negative 5, and c is 3. These is basic concepts. I hope you're getting all of these things correct. Some people paying a is 2x squared. Better than that. I hope you're seeing the look of disappointment. So a is 2, b is negative. The coefficients, these things are coefficients. You just want the number alone. Look up at the letter 2. A in this one is 1. B is actually 0. Ta-da-da-da. Stop and think about it. B is 0. B is the letter in the number in front of x. Do you see any x's here? This is a problem some of you all have in your senior x in everything. So b is equal to 0. C is equal to negative 10. The last one, don't be fooled with the last one. A is not 35. A is the number in front of x squared. X is actually negative 1. A is actually negative 1. B is negative 2. And C is 35. If you get all of these correct, you should feel very pleased with yourself. You have been learning your work. let's go back. So we need to learn how to factorize quadratics. Not all quadratics are factorized, but we need to know how to factorize those that can. So the idea is that we want to multiply A by C. Hold on. I see it as 600 people here. I don't want to waste all your time. All you want me to go in a little deeper and give you a little game and thing to play so you'll understand the logistics, or you want me to just factorize the quadratic, showing you how to factorize? You want me to go through the mechanics? I see plenty of people saying deeper or nah. Right there in the chat. Go deeper or nah. I waited. Tap a little delay. Go deeper, says Emmanuel. Go through the mechanics deeper. Yeah. Wise. Yeah, go. Right. I want me to go deep. So what I teach my students, and it kind of helps them to really understand the ideas that we're going to use in a quadratic, is a game and then 4 terms factorizing. What is the other word for 4 terms factorizing? That's a type of factorizing. It's called, start with G, or you can tell me that. So there's a game that I teach these students to play, and they get really good at it. And then all of a sudden, they could factorize quadratic equations easier. So here's the game. Yes, it's called grouping. The game is, I want you to think of 2 numbers, excuse me, that will multiply to give me 6. But at the same time, the 2 numbers must add to give me 7. What are the 2 numbers? That's the game. And I can give you a whole set of things like this, and we'll go, I'll give you like about 4, and by the time we reach the 4th one, it'll be real complex. But this is the concept that you must know to factorize a quadratic. This is the concept. So of course it's 1 and 6, right? Most of you all figured it out. It's 1 and 6 or 6 and 1. It can be vice versa. It doesn't matter. It's commutative, which means the order is not important. So 1 by 6 is 6. 1 plus 6 is 7. That's good, class? Everybody feeling good about that? How about if I'm giving you 2 numbers that add to give me it coming to me just now, it coming to me 4, but multiply to give me negative 12. When I add it, I get 4. But when I multiply, I get negative 12. What are the 2 numbers? Oh, all of a sudden, the difficulty has increased. We are on level 2. New boss. Now, a lot of you all can do this easy, but some of you all may struggle with this. You need a lot of practice in this. So the answer, Michael, is one. Michael, that you there, right? That bench boss. That bench boss from class. This man is normally be getting so much things correct in class. I started telling him, go on the bench, Michael. Take a little rest. Rest up. We don't need you on the field, right? Hey, that you, boy, Michael. All right, so 6 and negative 2 is indeed the answer. Introducing directed numbers. 6 plus negative 2 is 1. 6 by negative 2 is negative 12. So you need to become really skilled at seeing these things. Let me give you a next one. I want 2 numbers. I'm switching it up again. I'm saying multiply first. They multiply to give me 20, but they add to give me negative 21. What are these 2? What are these 2 numbers? What 2 numbers will do such a thing? What 2 numbers will do such a thing? 2 numbers I multiply to give me 20, but when I add it, I get negative 21. What 2 numbers will do such a thing? Yes, Alessandro and Kedron. Well done. We're looking at negative 1 and negative 20. Think about it. And negative by negative is actually a positive. So as I said, you need to get really good at this. And if you're struggling with this, the biggest clue that I can give you, the biggest tip to get better at this is always start looking at the factors of the product from the multiplication. Always start looking at the line with the multiplication. If you start looking at the addition, you will never figure it out fast enough. So you always look at the AC, the product part first. So I'm looking at 6, 2 by 3. That can never get 7. 1 by 6, boom, man. You understand? I'm looking at 12. 2 by 6 is, I need one of them negative 2 by 6 or negative 6 by 2. But I wouldn't put negative 6 because I want to add to give me a positive number. So it's negative 2 by 6. And that is the strength you need to develop. That is the muscle. That is the reps you need to do to get good at a quadratic. That is the reps. All right, so that's the game part. And the 4 terms is, okay, just give me a little chance there, yeah. Oh gosh, I know keyboard. Just give me 2 seconds there, yeah. Take a deep breath, make sure you're breathing properly. Fix your posture, you must be slouching. Fix your posture. Fix your posture. Just now, a little more. Take a stretch. Or they don't get distracted today. I know TikTok calling Somalia. Don't get distracted. Holy faith. Right. I was looking for some questions now. So what you need to get good at is stuff like this. This one is simpler than the last one. It's simpler than the game if you're starting from scratch. You should be able to see through these easier. How to factorize this. Now we're going to come across some more of this we're going to come across some more of this soon, yeah? I'm trying to find some nice ones here for you. You could even get weird stuff like this. So let's do the both of them. Yeah, so those of y'all who need to do more quadratic practicing and factorizing, those of y'all who need to do more quadratic practice, just look it up on my channel. Just look it up on my channel and practice, right? But this is factorizing by grouping. It's 2 steps. Yeah, you're doing basic factorization with the first 2 terms like that. What is common? What is common, class? Common in this is x. Hey, I don't want to write with the highlight. Common in this is an x. What is missing? Well, I need 1 to get back the x and a 4. This is a waste of time question. It's wasting my time. Maybe this was supposed to be x squared. So like put x plus 4. Yeah, this was supposed to be x squared. So like put x plus 4. Yeah, that was clearly supposed to be x squared. So x into x by x will give me the x squared. And we couldn't really understand what I do there. I just change this to x squared so you get into x there. Now the next step is once you get this x plus 4, once you get the x plus 4, put it back there. No, I refuse to say that word energy. Come on, man. This is class. Go to the back. Go to the back of the class. Go to the back of the class. So we're taking this x plus 1, we're putting it back there, and then you just need to find the missing spot, the missing number that will finish this off. And it can be 3. 3 by x, 3 by 4. And then you take the 2 together, the x, the things that are underlined, put it in one bracket, and you bring the next 2 like this. Now I have a video on the channel that x go way deeper. I have a video on the channel that go way deeper than this. So you can always check it out. I'll just do this one as well. What is common? A q. We have a q common here, and end up with p plus 2r. That's missing. Are you okay? Are you okay with that? Q by p is pq, and q by the 2r is 2q. The letters not confusing you, right? So I'm going to take the p plus 2r and just put it back here. But I might have to write it this way: 2r plus p. Normally, you don't even need to switch it around like that, right? I just write it this way so you can see it a little better. And what is missing? What is missing? What I need to put in the brackets already? R. You seen it? If I put R here, everything will be right with the will. R by 2R is 2R squared, and R by the P will be PR. So I just take this and put Q plus R by P plus 2R. Anybody becoming overwhelmed though, this revision is helping you. I know some of you probably need a little stretch. So this is grouping and this is the game. These are the 2 mechanics that you need to study and understand to get good at quadratics. If quadratics is something that you said I will You told yourself this, I will never understand that. You watch the students figuring it out, and you were like, I could never understand that. That square thing and factorizing and bringing it down. It's time to put a cross right here, right there. Go and learn it tonight. Every one of you all 569 of you all on this channel, can learn how to factorize a quadratic tonight. Hey, all you be quiet. Low down all your volume. Some cheering in the background. So all of you all will be able to learn how to factorize a quadratic tonight. Go and study it. You promise me. After this live done, you're going to learn how to do it. Trust me, this could be the difference between you passing CSEC and a pass. Once you get over that hurdle of quadratic, you can get over the hurdle of everything in maths. And this goes for any subject. Take your time and go and learn it. It is on YouTube, and I have it real nice. Go and learn it up. I have like 3-4 videos on it. Pick one and start to study it, right? Okay. Yeah, so where were we? We get real lost in the wilderness here, boy. So we need to factorize this quadratic. 3a squared minus 8a minus 3. The thing is, a by c is 3 by negative 3 is negative 9. Stay with me now, all. Stay with me. Negative 9. That's a by c. And then we have b is negative 8. So far, so good. Here we're going to activate the game. Time to activate the game. Now say game and it have something marked game score underneath me right here. Hey, I have a thing I'll get distracted fast. Anyhow, we're going to activate the game. AC is 3 by negative 3 and B is negative 8. What was the game? Think of two numbers that will multiply to give you that, but at the same time, add to give you that. What are the two numbers that will do such a thing? And the chat has it. The chat has it. The two numbers, I'm going to write back the other stuff. This is why you write it back, 3a squared. But you're putting the two numbers here. They said it's negative 9 and positive 1. And we couldn't put back the x there. That's how it works. Study it. Make sure you understand. And then what you have now? What do we have on the board? 1, 2, 3, 4. 4 terms, grouping. So it's time to do grouping. So you factorize by grouping. What is common? 3. Shucks, I put x, yes. Anybody see I put x there? Should be a. It was a. You can't change the variable then and then. Come on. Come on, Mr. Springs. All right, so this is going to be 4 terms factorization. So we're going to pull out the 3a like this because that's common. Put back a minus 3 there. You all agree? 3a by a is 3a by a is 3 squared. 3a by negative 3 is negative 9a. Put back the a minus 3 right here. We got it. That's the rule. That's how Springs show you how to do the thing. And then you just put whatever would make this truthful. 1 by a is 1a, 1 by negative 3 is. And then you join these two fellas together, the 3a plus the 1. And you join the a minus the 3. And that you there. That is you there. Max run. Give me my max. Run the max. Run the max. Don't write any people. So you factorize. Let me finish up this question strongly earlier. Let a star b equal 4ab minus b squared. And find the value of 2 star 3. And then they're asking you about this commutative thing. So what is this topic? What is this topic called? What is this topic called? Binary operations. Lenisha, the lessons that the students have working. Binary operators. Binary operators, in case you never know, now you're going to know. Hey, wait, nice space I running out of here. Binary operators is simply fancy substitution. What is substitution? If I tell you m plus n find m plus n, and m is equal to 3, and n is equal to 5, then you'll be like, okay, m plus n is really 3 plus 5, which is really 8. Let me put this in the binary operators way, right? Let me give you something a little more complicated. Let me give you something a little more complicated. That's too easy, right? That is substitution, by the way. So let me say m is 3 and n is, let me give you negative numbers and things. You know, we like to keep it spicy. So find the value of m minus n squared. Haha. That have a little more sting in it. M minus n squared. What the answer going to be? So we're going to put 3. And we're going to minus negative 5 squared. Let's see how we substitute things proper. You know how to substitute. This could come to it. Just straight direct substitution like this. Seen it? And then, so we have 3 minus negative 5 squared is actually positive 25, but don't change this negative. It's only that negative when I get x out. So you get 25 there. And you get 3 minus 25 is negative 22. Negative 22. Proper things. Let me show you how they can do this as a binary operator. They could write this and say m star n represents m minus n squared. What is 3 star 5? Oh gosh. Oh gosh. Preaching there. You see it? You're seeing it? You're seeing it? It's the same thing. Binary operators is really substitution in a fancy way. Proper things, Elizabeth. Have you seen it? So this is really, take the 3. You see now it's the two different formats, but the same thing. Take the 3 and substitute it there. Take the 5 and substitute it there. So this is 3 minus 5 squared. And you end up in the same, oh, sorry, negative 5. Negative 5, it was negative. I get too excited. So negative 5 squared, and you end up in the same situation. 3 minus 25 is equal to negative 22. You seen it? I hope all you are appreciating it. Are you seen it? So when they ask me a star b is equal to 4ab minus b squared, when they say that a star b is equal to 4ab minus what? B squared? 4ab minus b. They're making it up new every time, eh? They will create their own new thing every time. And then they come now and ask us to find 2 star 3. All they're telling you to do is substitute the 2 for the A and the B for the 3 anywhere you see it. So this is going to be 4 by 2 by 3 minus 3 squared. Proper things. If you understand that right, proper things in the chat. Proper things, right? A star B is 4ab minus b squared. So 2 star 3. And then you end up with your 4 by 2 by 3, 4 by 6, 24. Minus 3 squared minus 9. So you end up with what, 15? I think I see people writing 15 long time in the chat. A whole bunch of layers writing 15. I was wondering what you're paying 15 there for. So yeah, 15 is the answer. And you're collecting good marks. So I love this question because it's got proper 2 marks, 3 marks every time. And it's not a hard, it's fancy substitution. And then if they want to extend binary operators, this is what they usually do all the time. Ask you about commutative. There are 3 laws that you need to know about. And really and truly, there's only ever test 2. What are the 3 operative laws? Some of you almost see like, hey, so just tell me that. Don't ask no questions. 3 operative laws, just tell me. Just tell me, bro. Anybody know what's the 3 operative laws? Yes. 1 is associative. Well done, whoever your name is, the dummy. That what the person name is. D-O-M-I. Associative. Associative. Commutative. And distributive. So who is getting most love in this, in the laws? Distributive. Of course, distributive is getting most love by far. The most love. This is get a little bit of love, and this is really get no love. You're rare ever to see associative law pop up in CSEC in any form or fashion. So you can replace all these laws with one word that will explain what they're talking about. This one could replace with the word order. This just means which one comes first. Which comes first. And I'll explain a little more just now. Don't worry yourself. You can replace this with the word expanding, and everybody know what expanding is. Expanding, that is like when you have 3 into x plus 2. This is really 3x plus 6. So you see why this is getting most love? You're bound to do the distributive law in some form or fashion in CXC, maybe 4 times before the exam done. Associative law, the word you could associate with this, pun intended, is grouping. Grouping. And how the associative law works, I ran out of pages. All right, time for a new jam. It was nice. Stay with me there, just stay with me. I'm going to show you some important things here. So the associative law, I ain't spending too much time on this. I'm just going to mention what it's about. 2 plus 3 plus 4 is the same as 2 plus 3 plus 4. It means it doesn't matter which one I group first. I'll get 5 plus 4 is 9. I'll get 2 plus 7 is still 9. You understand? It doesn't matter which grouping comes first. I still get the same answer. So addition and multiplication obeys this law. Division and subtraction doesn't. For example, if I have 2 minus 3 minus 4 it's not equal to 2 minus 3 minus 4 if I do this. 2 minus 3 is negative. 1 minus 4 is negative 5, which is not equal to 2 minus 3 minus 4 is negative 1. 2 minus negative 1, you'll end up with 3. So they're not equal. You can spend how much time you want to soak down that. I don't really care about associative. There we go with the commutative law. Commutative law. Commutative law is always in CXC. It might show up in your paper. So the commutative law talks about if we change up the order. So let me say if we multiply 4 by 3, everybody know we get 12. And if we multiply 3 by 4, we still get 12. Right? The commutative law. Commutative law asks, all the laws ask a question. The question the commutative law asks is order important. That's the commutative law. So the laws really ask a question. The associative law asks a question. Is grouping important? All the laws ask a question. Is grouping important? And if it's not, then it obeys the law. If it is, then it doesn't obey the law. So this law is asking, is order important? If it's not, if you could swing it anyway, that means you obey the commutative law. For example, addition. 8 plus 3. I put the 3 in brackets, boy. 8 plus 3 is the same as 3 plus 8, which is this equal to 11. Order not important. Obeys the commutative law. 8 minus 3 is not the same as 3 minus 8. Think about your directive numbers. 8 minus 3 is 5, but 3 minus 8 is actually negative 5, not the same. So subtraction and division do not obey the commutative law, or we say are not commutative. They're not commutative. You're making sense? And this is what CXCs ask all the time. CXC like to ask, is it commutative? Anybody could think of another situation where CXC asks about commutativity? Anybody could think of another situation where CXC asks about this? Is it commutative? They ask about it in the binary operators. And they ask about it in what other topic is? See this happen all the time. Is it commutative? What other topic? You can see it happening in your exam. Yes, matrices. Hey, Emmanuel, you know your thing, boy. Matrices, Somali, Elizabeth. They ask about it in matrices. And I could tell you the answer one time. The answer is a big, fat no. It's not commutative in matrices. In matrix they'll ask for it in matrix multiplication. Matrix multiplication is not commutative. Only one matrix multiplication is commutative if you multiply by the identity matrix, which is 1, 0, 0, 1. But we're not doing matrix right now, and when we reach matrices 3, 4, 5 days down the road, we'll talk about that, right? Every day at 7 o'clock we're here. So matrix multiplication is not commutative. I don't want to digress too much. So what they're asking us is is this binary operators that where the binary by that we just solved. Well, you know, we just do a binary, right? I'm not making it up. A star B. It was A star B is equal to 4AB minus B squared. A star B is equal to 4AB minus B squared, and was 2 star 3. And I show you how to solve it. You just simply substitute it. It's 4 by 2 by 3 minus 3 squared. And at the end of the day, we got 50. So they're asking if it's commutative. How do we show if it's commutative? Well, you need to tiptoe over here and test the waters. You need to test the waters. Look at yourself and say test the waters. How are you going to test the waters? So you prove this, you prove if it's commutative by using example, which is not in mathematics the best way to prove things, but we will use this, right? And it's not. I could see this and watch it's not going to be commutative. How do we test the waters? You switch the order. Very good, Emmanuel. Very good. Emmanuel, feel free to jump in one of these off seats as we see, right? So we testing the waters. So we're going to switch the order. Simple as that, right? We're going to put 3 star 2. And what that will do? What do you think that will do, class? That means this is now A star B is equal to 4AB minus B squared. It's like the 3 becomes the A now, and the 2 becomes the B now. So we have 4, and last time it was 4 by 2 because we was replacing the A with 2. But now it's 4 by 3 by 2 minus 2 squared. We're still going to end up with 4 by 3 by 2 is 24. But when we take away, again, 2 squared is 4, we get 20. Ha ha ha. So it's not commutative. Once it doesn't work for one, you already show that it's not commutative. 99% of the chance, whatever you do, it's not going to be commutative. Right? Like 3 marks fall in the exam if it come, right? And just like that, we finish our next question too. Or you want to do another one? Another one? Class only at energy for next one. Normally these sessions is an hour and a half. We finish an hour and a half. All of these questions I have the solutions for, and I will send it to the classes in the student hub. But all the questions themselves, I send to the Discord channel. How many of you all get them? Or they say they want to do a next one. So let me do a next one. What type of factorization is this? What type of factorization is that? What type of factorization is this? Ooh, we get into the next one. What is this called? What topic? So tell me the 2 types of factorization and what topic. So this is basic. I'm seeing 16 and 4 and square numbers, but I'm not seeing a subtraction. M is not a square number, N is not squared. So that is basic. And then the next one, somebody for the difference of 2 squares. People, it can only be difference of 2 squares if you see that difference. What difference mean in maths? Difference mean subtraction. They're going to try to tie you by bringing 4 and squares and thing. If you didn't see no subtraction, just throw difference of 2 squares out the window into the cane field. Also, the M is not squared, so how are you going to be difference of 2 squares? And we know this is a quadratic. So let's do these really fast. This time I won't take so long, and then I'll be speeding a little more. So 16M plus 4M squared N. What is common? What is common? What is missing? What is common? Answer the first question. What is common? What do I pull out? What do I pull out? 4 could go into both of them, and definitely a M. What is missing? A 4. A 4. 4 by 4 is 16. That's all. Plus, already have the 4, already have the M. Oh, I need an extra M is M squared. So I'll put the M and the N. That's the answer. 1 mark. Everybody should get the basic factorization correct. Now, let's do the quadratic factorization. 4x squared plus 19x minus 5. Oh, it's time to show you all how to do it on your calculator, right? So what your calculator can do, so pause, we're about to learn big things here. Calculator and quadratics. What your calculator is made to do, your calculator actually doesn't really factorize a quadratic. Your calculator actually solves it. It solves for the roots, which is a little problematic which is why I'm not teaching you to factorize using only a calculator. And we will see this coming more handy when we are on question 8. Right now we are on question 2. When we are question 8, we have to do completing the square, the quadratics, and your calculator will come in real handy. But I just want to give you a little precursor on it. So let's say, what do we have here? 4x squared plus 19x minus 5. 4x squared plus 19x minus 5. What you'll do is open up your calculator, press mode again, go back on the same equation we was on earlier, press 5. Then, just now my brain freeze. Yeah, right, it unfreeze. Now we're going on number 3. We're going on number 3. Only want me to start over. I don't know, somebody up there want me to start over. I knew nothing about it want me to start over. Press mode. Press 5. That's like a selecting equation there. Right. And now you're seeing remember we wrote press 1 last time to go to the simultaneous. Well, yeah, I want you to press 3 this time. 3. That is the quadratic. And then you just fill in the coefficients. 4, 19. You see that ABC thing we're learning just now. Minus 5. And then you press 1 equal. Bang, you get a quarter. Write that down, write that down. X is equal to a quarter. I'm going to show you something just. And x is equal to -5. So the quadratic calculator doesn't factorize. It gives you the solutions for f of x equal to 0, also known as the roots. More on this when we reach this question. However, you can pull out the factors from this by getting this to equal to 0. Think about it. See if you could follow what I'm doing. I'm going to bring out the 4. So I get 4x is equal to 1. And then I'm going to bring out the 1 on the left hand side. So I get 4 minus 1 is equal to 0. That's the factor. That's the factor. That's it. That's one of the factors. 4x minus 1. And then from this, bring across the 5, you get x plus 5 equal to 0. So there's a next factor, x plus 5. This is how you factorize it using your calculator. It actually does require some skill in quadratic thinking, because you need to know how to take the solution and bring out the what we call the binomial factor. That's not, my camera is doing a kind of thing. Watch it. Always follow me around the room. I need to surely just not wasting time. I get distracted somewhere. All right. So yeah, so this is how you use the calculator to factorize quadratic. I have videos on the shop, you all could go and watch it. But how would you factorize this normally? 4x squared plus 19x minus 5, was it? 4x squared plus 19x minus 5. AC method, 4 by -5. I'm just writing this down. This is in my mind. -20. I want the number to I do it already. Why this feeling like I do this already? I'll do numbers to multiply to give me -20, but I have to give me 19. Somebody is saying the wrong things. Check yourself before you wreck yourself. And multiplies to give me -20, but adds to give me 19. -20 and -1 don't do that. -20 by -1 don't do that. It had to be 20 and 1. Well done, Michael, bench boss. So it's 20. It's 20 and -1. So you have 4x squared minus 20x plus 1x minus 5. What do you want to solve this? No, you factorize it. So it's equal to that. Then you have, this is 4 terms of grouping. So we're going to pull out 4x into x minus 5. I'm moving a little faster. X minus 5, because I did this already in a slower pace. So 4x by x is 4x squared, 4x by -5 is -20x. And clearly we'll have a plus 1 missing from there. So then 4x, Lisha, what do you mean what about the sharp? You ain't seen people say I had the videos on the sharp. You feel the line. So what about the sharp? You could go and look it up. Search Kerwin Springer sharp quadratic factorization. But still, you would need a pretty, sorry, I did a mistake. Getting distracted here, boy. Is negative, is -20 and 19. So then this had to be positive and -1 here. Apologize earlier if anybody was getting frightened. Apologize. I strongly apologize. Yeah, so what's going to happen here is a negative. So what I'm saying is that I have videos on the sharp how to factorize. So you could search Kerwin Springer sharp quadratics and you'll see it. I have a nice little thing from way back in the days. So 4x, a lot of you all giving up, like quadratics is something, if you never really learn it before and you're watching the students and everybody doing it and solving it, you could feel like you can't make. I'm telling you all, you could learn it in time for exam. Don't give up. Learn it. Pass maths this rounds. Don't wait. Just do it over. Pass it this rounds. Anyhow, so yeah, we're going to group the two out terms together. So we're going to get 4x minus 1 by x plus 5, and we factorize it. Wait. Did we already get that when we do the calculator method? Hey, 4x minus 1 by x plus 5. 4x minus 1 by x plus 5, and we cook in it around. Okay, yes. Let's go and get the next part of the question done. So what topic was this, guys? What topic was this? This topic was called, anybody had get it correct? Linear equations. And it also has some distributive law happening up there. So we have 5 minus 2 into x minus 1 is equal to 4 into 3 minus x. We're going to distribute 5 minus 2x plus 2 is equal to 12 minus 4x. So far, so good? So far, so good? 5, and there was a little trick here that happened. I hope you all paid attention to it. We minus 2 by the x, we get that. But when we multiply the negative 2 by the negative 1, it actually became positive. Something like that is going to happen in your exam, guaranteed. You're going to get some negative sign distribution across a bracket. So some kind of thing like that. So you gotta be prepared. Stay woke. Let's group these terms. So this is 5 and positive 2. So that's actually 7 equals to 12 minus 4x. Now what a lot of people might do is say this is 5, take away 2. The negative sign, the signs belong to the term that come after it. You see this negative sign? This is property of the 2x. So this could only work with the 2x, guys. Understand? You can't go with the 5 or 2. So bring across the 7. So you get 12 minus 7. Bring across this negative 4. So you get negative 2x plus 4x. This will boil down to 2x is equal to 12 minus 7, which is 5. X is equal to 5 over 2, hopefully. So what do you feel about that? Right now, the only thing I'm feeling is hungry. I'm feeling hungry, Ali. Yes, now, feeling hungry. 10 out of 10. You could actually do this on a calculator, but that's the next time. I'm feeling too tired to show you all this. And this easy thing. Easy thing. But I put that on calculator. Make B the subject of the formula. Make B the subject of the formula. A is equal to half A plus B. H. What do you think this topic is called? This is what this topic is called. Subject of the formula. AKA, also known as transposing. Normally at this time, people is dip, but all is still here. So I'll keep going. So half of A plus B by H. Maybe we'll finish in 10 minutes there, right? Half A, what it is? A is equal to half A plus B plus A. Where's this formula? Where is from? Where is from? Area of a who? And there's something CXE loves. Right now, CXE watching this with love in their eyes. And like, we love this. What's the area of a trapezium? Yeah, see, you're going to get that in your exam, so make sure you know how to utilize this. But what they want to do now is to just make B the subject of the formula. We need to isolate B by itself. So we're looking at B, and we're going to try and hunt him down and get him by himself, right? So the first thing we're going to do is get everything that is not B out of the situation here. Come out. So I could get the half out by just multiplying both sides by 2. like this. How you all feel about that? How you feel about that? And that making sense? So come like a bring across the 2, then I was dividing and multiplying. Or multiply both sides by 2. And then I could get rid of the h one time, or I could distribute the h, bring across, then divide everything by h. But I feel the best thing is to get rid of the h one time. What is the h doing on this side? I can't get rid of the a. The a is trapped in the bracket, so the h is the next man to go. The h is, somebody say why not the h first? It could be anyone, actually. H or the 2. What the h is doing? The h is multiplying, right? So when it comes across, it will be dividing. Do you agree with me that the next line looks like this? Next line would look like that? Or in theory, it's like if I divided both sides by h, but we kind of skip this step by the time we reach form 5. You understand that you're kind of bringing it across. Like, we don't think about dividing both sides by h. We think more in terms of bringing it across and inverting the operation. Last man to go is the a, because we want the b. Last man to go is the a. Remember, we want the b by himself, right? I highlighted it. So the a is adding on to the b. So if I want to bring him across, he will actually subtract. And that's the end. That is him. B is now the subject of the formula, 2a by h minus a. Yep, and everybody like this self-B, and you collected 2 marks. Solve the inequality and then represent the number line. This has become increasingly popular. So you can look out for something like this making an appearance in the people them exam. It's become very popular, actually. So it always had a degree of popularity. This is called inequalities, of course, but they also want you to take it a step further and express the inequalities on a number line. So let's do a couple. It's more useful for you all to understand the theory behind it so you can do any question in the exam. There are 2 traps. I call them 2 trap cards. So if you ever see anybody using them words, you're going to hear first, ladies and gentlemen. 2 trap cards, 2 situations to stay woke about. These are things that should keep you up at night. What are the 2 situations? Anytime you're doing inequalities, you have to stay vigilant. Let me don't make you sad. You're actually vigilant. You're actually, focused. What are the 2 situations that you should be looking out for anytime you're doing inequalities? So anytime you're doing inequalities, these are 2 situations you should be looking out for. Anybody know what the 2 situations? Yes, thank you, Lenisha. Lenisha, them lessons in the student hub doing wonders, boy. So the first situation is when you are multiplying or dividing by a negative number. That is situation number 1. When multiplying or dividing by a negative number. What's the next situation? What's the next situation? 2 things that should keep you up at night when you are doing inequalities. Linear inequalities. 2 trap cards, 2 situations. The next one is overlooked. This one, people is look out for this one. The next one is somebody asking me to go over. It's not nothing to go over here. This is English. If you think you had to go over this, you're overthinking it. And when I do the question, you'll understand what I mean. This is just to memorize the words right now. When you swap both sides completely, don't put that in brackets, completely. Because some people think when you bring across thing, you have to switch side. No, it's when you swap both sides. Okay. Remember equations, linear equations look like this. X plus 3 is equal to 10. You bring across the 3, it turns negative, you get x is equal to 7. Everybody know about that. You have 2x is equal to 15. You bring across the 2, it turns to divide. 2x is equal to 7.5. Everybody know about that. All we know about that. Well, if you're using inequalities, it's the same thing, you know. If you're using inequalities, like inequality symbols like this, don't frighten, it's the same thing. Greater than 7. If you're using inequality symbols, it's the same thing, except the trap cards. except the trap cards. There are situations that will happen in the exam, and it's happened half the times. Half the times they bring these inequalities, they will put in a trap. And the trap will require you to switch the direction of the sign. Let me show you the two traps, how they could occur. If I told you X represents the age of boys in class, and I told you all the age of boys in class is over 15, do you think I could mathematically, I want you to think about this. Do you think that this mean the same thing like this? Or you think these two things mean the same thing? All the boys in class are greater than the age of 15. 15 is greater than the age of all the boys in class. Do you think these things mean the same thing? No. If I'm saying 15 is greater than X, this means X is like 14 going down the road. But we know it's really X is greater than 15. That is a trap, which means anytime I want to switch around, anytime I'm feeling froggy and I want to jump out and switch around the two sides of an inequality, you have to swap the inequalities like this so that it remains logically correct. That is a trap. And that is the biggest trap that students fall into in the exam. If you swap both sides, the entirety of both sides, you have to switch it. I'm not saying like if I have X plus 5 is greater than 10 and I bring across the 5, I need to swap it. No, this works. I could stay like that. However, if I started off with the X plus 5 on this side, and this is usually how it's happening, and I bring across the 10, did I bring across a 5 and minus and get 15? Already going on with me, why? 5D. I'll pretend that I didn't see that. and I bring across the 5. X minus 5 is 5. And I reach here. And now I want to say, hey, I want to bring the X on this side, and I like to have my X's them on this side. I like my X's in the back of my life. So I want to put the X on this side, and I can put the 5 here. If you only put back that sign CX, you go on a maths. You have to switch the sign like this. The open part stays pointing the X in this situation. If it was the pointy part, it has to stay pointing who it points. So that's one of the traps. The next trap is if I have negative 2x is less than 10, and I have to bring across that negative 2, this is wrong. And I'm wrong there one time. To make it correct, I have to swap the signs. Now I could go through the evidence to show you why this is so. And I did in class, but I ain't feeling to go through it tonight. Sorry, just take my word for it now. So this is X is greater than negative 5. So anytime you multiply or divide by a negative number, switch the sign. Let's go through the two traps again. What's the two traps? If you swap both sides, switch the sign. And sometimes the signs have like this extra line in it, which means less than or equal to. And if you multiply or divide by a negative number, now you don't want to pay attention to this, you can leave this out, but then you're leaving out your maths. Multiply, divide by a negative, and it's a simple thing. It might seem complex to you right now because if you don't know it, but it's a simple thing. It's a simple thing. Somebody don't know the lyrics to the whole of Kendrick, 2 songs that he drop on Drake. They don't know Drake have a daughter and all kind of, but you don't want to learn this one thing. So organize yourself. All right, so let you go back to the question here and see if any of the traps happen. None happen actually. And I feel sad when the traps don't happen actually. So we have 3x minus 14 is greater than or equal to 1. 3x is greater than or equal to 1 plus 14. We didn't multiply or divide by a negative number. We just brought across the 14. So you get 15. 3x is greater than or equal to 15. X is greater than or equal to 15 divided by 3. So this means x is greater than or equal to 5. Now, how do we show this any number? What? Why this number line like this? Did I do something wrong? Bring that across, divide by 3 thing. Yeah. Why my number line ought to be looking so, boy? CSEC really give me that number line with the little edge there, why? Yeah, because what happened? I need to go by the 5 and make a circle, right? That's the man in the man of attention there right now. That's the man in for importance, the 5. And then I need to point in the direction that the x will let me know x is greater than 5. So I need to point this way so that looking kind of not too good. That looking kind of not too good day. Also, because I'm seeing this little underline here, that means x could actually be 5 as well. So I'll shade in that because I want my maths. So usually, like as what little numbers and thing here too to help the arrow feel like he doing something, but they didn't. So, but anyhow, you have to circle and put that. How y'all feeling? All you want me to do this one in lightning speed, all you good day? If all you good day, write a good day in the chat, or if one more for real this time. One more for real this time, all you're good with algebra. Or you could search Kerwin Spring and Algebra. You could watch what I do last year. You could watch what I do year before. Or well, people saying they're good. Good. One and I say one more. Most people good. Most people good. Most 3 more. I'm gonna say 3 more, yes. Just say how going on with you, boy. One more, or the one more people coming in. Do it fast. Or I'm gonna do it lightning speed. Like do it lightning speed. Lightning speed, right? Top speed, we ain't waiting for nobody. We just blazing through this, right? And this kind of repeating some of the concepts we use already. So 9a squared, this is difference of 2 squares. The answer is going to be 3a minus 1 by 3a plus 1 when you get the square root of each term. This is grouping. You see in 4 terms, so you don't know it's grouping already. What is common in these two? Nothing. So what we'll do is rearrange. So I'm going to rearrange this for fs minus fr minus qr plus qs. Now we're looking properly. What is common? So if this happened, that big tip I gave you, just rearrange. Pull out the f, s minus r. Why did I write x? So I'm expecting s minus r to be here. Pull out the, well, just pull back the s minus r one time. Oh, gum, the r and the s kind of mix up. Let me just switch it around. Let me just switch it around now. Okay. You could do that, or you could work with it just so, minus qr, no, plus qs minus qr. All I did here is just rearrange, right? But the positive belong to the qs when I'm moving them, I'm moving. So now you see now I'm going to pull out the q, and I have the s minus r there again, and I'll end up with f plus q into s minus r. So sometimes with grouping, you have to rearrange them to get them in order. CSEC will purposefully try to hot up your head by mixing it up. Just rearrange until you see a common factor and nice things will happen. I say I'm going fast, so I'm not going to waste time. This one is linear equations again. We have 5 over 3x. 5/3 x is equal to negative 10. Bring across the 3 is dividing. Or we could multiply by the whole of the reciprocal of this. But let's do it step by step. X is equal to negative 10 by 3. I already know that's going to be negative 30. That's 5x, sorry. The 5 is still there. Then x is equal to negative 30 divided by 5. And I had to come across here because I'm blocking. So negative 30 divided by 5 is negative 6. X is equal to negative 6. Well, then not. So x is equal to negative 6. One mark for that way? Stingy. So this one we actually need to solve. Calculator could quickly tell us the answer. So let's put that in the calculator. I already have it preloaded, but I'll press mode 5 for equation, 3 for quadratic, 3 is the A, 7 is the B, and the C is actually negative. When you're using negative, you have to, that subtract, you have to put in this symbol, negative 6, press equal, 2/3, and negative 3 is the answer. So x is equal to 2/3, and x is equal to negative 3. Putting those two things should actually give you full marks. But of course, we want to see some working. 3x squared plus 7x minus 6 is equal to 0. 3 by negative 3. 3 by negative 6 is negative 18. Two numbers that will multiply to give you negative 18, but add to give you 7. Well, what are those two numbers going to be? It's going to be plus 9 and negative 2. Revise your quadratics if it was hard for you to find those two numbers. 3x into x plus 3 And then we put back the x plus 3 here. And we're going to put a little -2 here to spice it up. So we have 3x minus 2 and x plus 3 is equal to 0. So since we are solving, we don't stop there. Pay attention, people. When you're solving a quadratic, you don't just stop by the factorized part. If you're factorizing, you can just stop there. When you're solving, you need to say either this factor is equal to 0, 3x minus 2 is equal to 0. So x will be 3x is equal to 2, and x will be equal to 2/3. Or x plus 3 is equal to 0, and x will be equal to -3, which was the answers that your calculator gave you. Long time. So you're feeling good. Are you looking like Jake in the thumbnail? Are you trying to make me publicly pick a side in the rap battle? This is the formula. This is actually physics. Physics people, how are you feeling? Are you register for the 12-hour physics crash course yet in the student hub? Yeah, if you want to register for anything in the student hub, this is number +1 86831011306. You can WhatsApp that number and register for crash course, 12-hour crash course and things for physics. Physics people, I want to do some physics on YouTube too. You know? What topic in physics is the hardest topic? Anyhow, they want to make. Oh no, they have 1u plus 1v equal 1f, and they told us u is 2 and v is 3. This is basic transformation. Basic transformation. Substitution. Where's my mind right now? Basic substitution. So I put 1/2 plus 1/3 is equal to, that's a f, 1/f. 1/f. I shut it down there. This is a little difficult, eh? Let's go to the paper with this. It's a little difficult for some people to figure out how to get the f to come up. So let me go on the paper and see what we're going to get. We have 1/u. Hey, I need a clean sheet, boy. So we have 1/u plus 1/v is equal to 1/f. And they're telling us that u is equal to something and v is equal to something. U is equal to 2 and v is equal to 3. So you have 1/2 plus 1/3 is equal to 1/f. What do you do, class? Well, you're going to need them a little LCM day, brother. You need to merge this into one fraction. You're smelling that? One fraction we need, brother. You can put it in your calculator to a half plus a third. Where's that? Where your calculator telling you half plus a third is? Side 6 or some kind of thing. So anyhow, so 2 and 3, LCM is 6. 2 could go into this. 3 times 3 by 1 is 3. 3 could go into this. 3 could go into this. This one asking if I could do the light skin stay. 3 could go into this 2 times. Hey, all you not locked in enough. Remain locked into the end, please. 1/f, so I get 5/6 is equal to 1/f. So you might be thinking, this ain't helping me out here now. But you're one step away from the answer. You're one step away from the answer here. One step to go. Where's this step? We need f to be standing up strong by itself now. Right now we need the denominator weak. So how are we gonna do it? The good old reciprocating. We're gonna flip this side. So this gonna be f/1, which is f. And we have to flip this side to 6/5. Niceness. Therefore, f is equal to 6/5. And we're good to go there. What do you feel about that? That was an interesting question, actually. Very interesting. And the last question for today is to make u the subject of the formula. So this is the lens formula. 1 over the object distance plus 1 over the image distance is equal to 1 over the focal length. You don't need to know that unless you're in physics. But they want you to make who? Make u the subject of the formula. Make this guy stand up by himself. So first manner of business is to get rid of that 1 over. First order of business is to get rid of that 1/v. What you doing there? So you're gonna put the 1/v on the next side. Like that. Nice. So 1/u is equal to 1/f minus 1/v. Next order of business would be we need u to stand up strong. So we could flip. And I think we could just flip them two just so. If you do that, you're wrong. You can't flip things just so, brother. You have an order about that's some kind of order about yourself. You can't just be flipping things all over the place. So you is Jesus, you flipping tables, and you can't just be flipping things all over the place. You can flip stuff if it's one. It needs to become one. So that's a little problematic. Let me see how we can do that. So you're gonna put FV here. That's the LCM. F could go into FV times. This we do this already, in case I didn't realize. V could go into FV, F times. Now you could flip. Now you could flip. So you could flip this and then you can end up flipping this. And you get, take your time. Take how much time you need. Take your time. Take your time. Watch it. When you understand it, type IU in the chat. That was actually a pretty clever question because they combine linear equations with transposition with algebraic fractions. Like this question. This question had a little spice in it. So just like that, we finish our study of algebra. There was 2 more questions. Let's see what was new in the questions. This is subject of the formula. We do that already. This is factorization. We do that. This is taking worded expressions and making it into algebraic expressions. This is something that we need to do. Y'all, don't run away. Hold on. Stop. This is important. Stop. It can take 5 minutes. What is this topic called? We need to come back to this. Let me just watch the other one. We do that. Worded stuff. We do that. Yeah. So, but we need to touch this one earlier. We need to touch this one. Stop. I'm sorry for them who. No, we need to do this. I'm say boss man. No. We need to do this. This is variation. I need all you to see this. So they say in the circumference C of a circle is directly proportional to its diameter. Sometimes they say vary to x squared or y squared or v squared. This time they say it vary directly proportional to the. So this is written like C is varying to D. The circumference of a circle is directly proportional to its diameter. Now, it's directly proportional. You see, this is it. They want us to represent this information as an equation. Look at me, look at the paper, look at yourself, and ask and answer this question. Is this an equation? That's an expression. That's an expression using this proportionality symbol, the fish-looking thing. I see somebody shouting fish just now. Look, a fish. That's proportional. This is not an equation. You start off like this, but then you put the equal sign and you put a constant. But in this case, they told us the constant is actually pi. So circumference is pi d, which we already know actually, and we get the mark. That is not what I want to share. Somebody must be watching. I know that. This is the part here. What is the key for variation question? Class, those of you all who in my online class, what is the key for solving a variation question, a proportionality question? If it was inversely, it would have been like this. If it was inverse, and you put the constant up here, constant is usually key. What is the key to a variation question? The key to a variation question is to find the constant. The key to a variation question is to find the constant. How do you find the constant? Use known values. So we have our setup. C is equal to pi d. We're going to use these values because we know them. A lot of times they bring it in tables. Sometimes they bring it in the sentence. So the known values are that when D is 3.5, C is 11. Substitute. 11 equal pi 3.5. What? C is equal to pi D. Oh yeah, that's correct. So yeah. So pi is equal to 11 divided by 3.5, which is what? Somebody tell me what is that? Now we know pi is approximately 22 over 7, or wait, now like 22 over 7? Like 22 over 7. Multiply this by 2, you get 22. Multiply that 2 by you get 7. All right, well. You get it constantly. 22 over 7, or 3.14 approximately. Once the long decimals is come when you divide it by 7. So we got to go then. How are you feeling about that? We get the constant. The key to proportionality is getting the constant. So now I could say when D is 7, C is equal to pi D. C would be equal to 22 over 7, which is pi, multiply by 7, you get 22. Making sense, class? Making dollars? Making sense? And when C is equal to 44, you see what I'm saying? C, 44. Then D, to find D, we'll have C is 44 is equal to pi, which is 22 over 7 by D. Bring across the 7, so you get 7 by 44. Bring across the 22, you divide. You could spend how much time you need to check and see what I do there. And in the end, you will get D is equal to 14. Or in this case, C is equal to 22. In this case is X, right? C is X. X is equal to 22. And Y is equal to 14. Bang, bang. Practice this. All of the topics that I talked about today, I actually did them on YouTube as a separate short video that you can watch to get really good at. 2 hours of maths. For algebra, this was a really, really, really good content that we did here. Even though we started off rocky for the first 10 minutes, I need to send a message. You could probably type the message in the, when the video done, but type the message for me now. Tell the people it starts off a little rocky for these first 10 minutes, but this is a really crisp session. It was a good session. Emmanuel say, Uncle Springs, I need a free Casio because my shop going on 6 years just now and Father's Day coming up, so I need a little gift. Yes, a father. Emmanuel, if you're from Trinidad, Emmanuel, what's your last name? If you're from Trinidad, we go organize it. We go organize it. Emmanuel, what's your name, boy? I need to know your name before next Emmanuel take a calculator. Right. Emmanuel Diet. I don't even know how to screenshot with this thing. Just show them this part of the, you screenshot this part now, record this part or show them this part of the video, message the student up and tell them, so say, you will get a free calculator and meet me somewhere now. So, 1868, where's the student up number? 4724221. That's 1868. And you will get a free calculator, bro. You can meet them in like Center City Mall or something in Shogunas. They go organize here. And Candy, what is your full name? You and my boy will get a free calculator. So this is Emmanuel. And Candy, what is your name? It was Emmanuel Diet. Bro, I only had 2. The man only gave me 2 to give away. Candy, what is your name there, Candy? Or it's actually not Candy, it's Kristen Walker. Kristen Walker. The organizer yourself, WhatsApp this number now, and tell them you come and collect it whenever you can collect it. Exam soon, so try and collect it Monday or Tuesday. They will meet you somewhere in the Shogunas area. Next session is tomorrow, 7 p.m. sharp. Today I was 1 minute late because I don't have a keyboard. Not working. 7 p.m. sharp, we're going to be doing geometry. I will load it up. I can load up the video right after class so you can plug in. Subscribe. What else? What other questions are there for me? Love and blessings. What are we doing tomorrow? Geometry and things. You're supposed to do construction too, but I'll see if I can pull out some construction tools for you. But it'll be kind of hard for me to do construction with just like this. Tomorrow is my mock. Church tomorrow. Yeah, church tomorrow. Oh yeah, right. I'll go and practice. Thanks for the reminder. Love and blessings. Anything else to tell you, boy? So remember, we have the 12-hour crash courses for the student up for a lot of different subjects. This is the number you can WhatsApp at. WhatsApp this number to sign up for the student hub. If you're going to do lessons, if you're going to do CAPE next year and you need lessons in any subject, MOB, some studies, Caribbean studies, biology, chemistry, physics, pure maths, applied maths, wherever you need, student hub is this spot. Student hub are the lessons for economics. Yeah. So most of the teachers follow styles similar to mine. They have their own style, but it's very engaging, and we keep getting better and better teachers from all over the Caribbean. So organize yourself. All you need vectors that coming up. Circle theorem, we didn't do that yet. I'm going to practice the keyboard. Yeah, blessings, and tips to someone. Yeah, you need to do something that I wasn't doing all the other years. You need to put in the work consistently. And may actually still try out for this exam, but you may need to go consistently for a year or 2 years straight. Every week you're doing work bit by bit instead of waiting till too late. Biology, yeah, we have the crash course for biology. The crash course for chem already passed because chem exam right around the corner. But you all WhatsApp the number and sign up. Yeah, so maths is not unlimited. Plenty of people think maths, it's just new things. It's the biggest syllabus for CSEC, but not unlimited. Every time you keep learning something new, you're getting better. Think about that, and you can finish. So be patient with yourself and continue. Blessings, Gil. Nice meeting you in the meet and greet. Ravello, bless up. Nice candy. They got link here. Just let them see the screenshot here. Nah, I can't say that. What, this man counting down by 3, 2, 1. I'm not answer any Kendrick or Drake things right now. Tuition is the boy for POE and the man for POE and YouTube. Don't forget the light skins there and that. All right, tell you. Love lessons. Enjoy the rest of your weekend. Enjoy the rest of your weekend. Some of y'all have exams bright and early on Monday. So enjoy. Love and blessings. See y'all tomorrow.